Welcome to Let's Calculate Something. Today I'm standing on deck 11 on the Carnival Breeze cruise ship, and I'm wondering how far is that horizon away from me? And how far would it be if I was at various levels on the ship, right? So what we're going to do is we're going to derive an equation that will tell us that, and then we're going to spend some time calculating how far out the horizon is, how far out you can see on the horizon from various points on the ship. So watch the video to the end and you'll get the full experience. Looking forward to solving this problem. Today we have a really cool problem. Recently I was on a cruise ship and I was looking out from like one of the tall decks, and I just really wondered how far out I could see on the horizon. And I've always wondered that, actually. And so I figured out how to solve that, and I want to share it with you. It's going to involve calculus, and it's going to involve the equation of a line, or figuring out the slope of a line. And both of those videos you can find there. The calculus one goes over how to use the chain rule to take a derivative, and the line one goes over that slope piece. So if you want to watch those videos before you watch this one, it might be helpful. But I'll do some explanation on this one too. You can watch it first and maybe go back there if you don't understand. But we're going to kind of break the problem down into a couple different parts, and we're going to solve it and then calculate some distances based on the height of the ship, okay? Or the height we are at on the ship. So the way I solved this was I recognized that the Earth we could represent as a circle. That's simple. The diameter is about 8,000 miles, give or take. And we just have to represent this as an equation, solve it for y, and then we have to get the equation for this line where our height is wherever our eyes are to the point on the circle that's the horizon, which represents the horizon of the Earth. If we get that equation, our slope, figure out what the slope is. And then, the other piece that's crucial to this is that at any point on this circle, if we know the tangent, that is the slope of the line for that circle. Okay, that is the slope of the point on that circle. All right. The way we find that is with the derivative. So let's start by just figuring out what the equation of a circle is. And it's pretty simple. It's y squared plus x squared equals r squared. Now, our r is going to be 4,000 miles, but I don't want to write 4,000 throughout this whole thing. You can see the algebra is going to get pretty hairy. So I'm just going to keep it as r, and we'll plug it in later. Okay? So let's solve this for y. All right? So we get y squared equals x squared minus r squared. Then y equals the square root plus or minus the square root of x squared minus r squared. So why is there two answers, plus or minus? Well, because anywhere I am on x, if we call this x, we call this y here, anywhere I am on x, I have two y's. I have one up here and one down here. The positive represents the one up here, and the negative represents the one down there. But we're not interested in the one down there, so we're just going to take that one. Okay, so that's helpful. So let's write that down. That is, at any point on the circle, I could define it with x and x squared, the square root of x squared minus r squared. And actually, that is backwards. That is backwards, sorry. I have it wrong. It's r squared minus x squared. Sorry about that. So this is r, this is x. Already goofed this. This is a lot of algebra, you'll see. Hopefully I won't make any more mistakes. Okay, so that's a really important point. We'll call that 1. Now, if we take the derivative of this, then we will know the slope of the tangent anywhere on the circle. And so this really equals r squared minus x squared to the 1/2. And so taking derivative using the chain rule, we'll take the outer part first. We get y prime equals 1/2 times what we had started with, the inner part. Then we subtract 1, so that becomes a minus 1/2. And we have to take the derivative of the inner part, which is minus 2x. All right, and so simplifying this, we will get, I'm going to write it down here, you'll see y in a second, y prime equals, simplifying, we can cancel out the 2's, minus x times, it equals minus x divided by r squared minus x squared, and that's the square root, because that's what minus 1/2 means, 1 over the square root. So that is y prime, and so we've got that point. Now, we need to get the equation and the slope of this line here. What's the slope of that line? Okay? Knowing that we're starting at the origin, we know that x is 0. Okay? So let's write that down. This is 0.2. All right? So we know x, this is a point here, this x is 0. Then what is y? Well, y is going to be r plus h. So the radius of the earth plus the height above the earth that we are. That is going to be, that's the value of r, of y. So now we have 1, 2, and we have the slope. So now all we need is the slope of this line. Well, we have the 2 points. So since we have 2 points, we can find the slope. And that is going to equal, we take y1 minus y2 divided by x1 minus x2. All right? So what is that? So y1 is the square root of x squared, of r squared, keep doing that, r squared minus x squared, right, minus the quantity r plus h. We have to subtract the whole thing, divided by x minus 0. So we know that the slope, write that in red, sorry, that the slope equals the square root of r squared minus x squared minus the quantity r plus h divided by x. Okay, so let me erase this, and then what we have to do is set this tangent, which is also the slope of the circle, equal to this slope of that line, and we will be able to solve for x. It's going to be pretty nasty to get it, but we're going to solve for x, and that's going to tell us the distance between our point, which is the 0, the origin, out, that is x. Okay? So let's go ahead and calculate that. So we set these two equal. I'll erase this. We'll erase this. We're going to set this to this. So y prime equals m, and that means minus x divided by the square root of r squared minus x squared equals m, which is the square root of r squared minus x squared minus the square root minus the quantity r plus h, no square root there, divided by x. So we have to solve this thing for x, okay? And it's not going to be too bad. What we're going to do is we're going to cross multiply this. I'm going to cross multiply and set those equal to each other. Okay? So we're going to get minus x squared, that's this part, equals the square root of r squared minus x squared times the square root of r squared minus x squared minus the quantity r plus h. Okay, so now we have to dig x out of this. And the first thing we're going to do is multiply this through. We're going to get minus x squared equals this times this is just r squared minus x squared. And we have to multiply this through this. We get a minus square root of r squared minus x squared, right? Minus r plus h. My pen is dying. All right. Now we can see that this x squared will cancel, which is nice. So now we just have to solve for x here. We're looking for this guy. So bring this over. We get minus r squared equals minus the square root of r squared minus x squared times, or I'm sorry, minus r plus h. This is not minus, this is times, sorry. This is times, sorry, okay. So now we can divide through by minus r plus h, and we get r squared, because the minuses are going to cancel, plus h equals the square root of r squared minus x squared. Okay? So now what we have to do is square both sides, and then we'll be able to get to the x squared piece. So if we square both sides, I'm going to start up here. We're going to get r squared divided by r plus h squared. That whole thing is squared. Equals r squared minus x squared. All right, so we got that far. I'm going to erase this, give us some room. Okay, and I'm going to continue. All right, so now what we have to do is bring this over to the other side and then get rid of this minus 1. So if we subtract r squared from both sides and then multiply that by minus 1, it's just going to flip what we subtracted over. So this would be, this minus r squared, so now it's going to be r squared minus this. So r squared minus r to the fourth, let's multiply this out, over r plus h squared, right, equals x squared. We did a couple things there. We brought this over, we brought the minus 1 over, and we squared both of these. Okay, so we end up with this. Now we can factor out an r squared. So we'll factor out an r squared. That means this is 1 minus r squared over r plus h quantity squared equals x squared. So now we can solve for x finally. So if we take the square root of both sides, we're going to get x equals r, because we're going to take the square root of r, times the square root of 1 minus r squared over r plus h squared. And that's our final part. That's our calculated formula. That's our final formula. And so what's nice to do now is to look at, does this make sense? So what would make sense is that if we were on the surface, if our eyes were right on the surface, okay, looking out, how far out could we see? 0. So let's see if h is 0, this better give us 0, okay? So if h is 0, then that's r plus 0 squared. That's r squared. R squared divided by r squared is 1. 1 minus 1 is 0. 0 times r, the square root of 0 is 0. And 0 times r is 0. So that means this is probably correct. So now what we have to do is substitute in the 4,000, and we have to figure out h. So let's do that first. We'll do x equals 4,000 times the square root of 1 minus 4,000 squared divided by 4,000 plus h squared. All right. Now we have to figure out what is h. So depending, I'd like to do it in terms of the decks. So depending on what deck I'm on, how far out I could see. All right. So if I do that, we'll use this one here. So if I do that, let's say I know, I looked it up, that the distance between the water line and the first deck is about 10 feet. So H is going to equal 10 plus the first deck. If I'm on the first deck, that's it. It's 10 feet. So I'm going to take the deck minus 1 and then multiply it by 9.6 feet. That's the distance between decks on the cruise ship. So if you're on deck 1, if you're on deck 2, deck 1 is 9.6 feet below you, and deck 3 is 9.6 feet above you. So if I'm on deck 1, then this is 0, my height is 10 feet. If I'm on deck 2, then this is 1 times 9.6, then my height is about 19.6 feet. So I was on deck 11 when I was watching, when I was looking out. So if that's 11, then H is going to be 106, right? Because that's going to be 10 times 9.6, that's 96, plus 10 is 106. So if you plug 106 in here, what do you think will happen? Well, I'll tell you, you get the exact wrong answer. And that's because this is in feet and this is in miles. So we have to convert this to feet. All right, so H is going to be all of this divided by 5,280. So this is divided by 5,280, which is, this equals 0.02. So now we have everything we need to calculate how far out we can see from deck 11 on the cruise ship I was on. So we'll plug in 0.02 here. And this is going to be, you put 0.02 right in there. And if you work this out, so you got 4,000.02 squared divided into 4,000 squared, then subtract that from 1, because this is a little bit bigger than this one, so this will be less than 1. Subtract that from 1, take the square root of it, and then multiply that by 4,000, you're going to get your answer. So for deck 11, the answer is, this is 12.67 miles. And I think that sounds, let me write that meter, sorry, all that work, I'm going to write the answer sloppy. No. 12.67 miles is how far out you could see. And so that's pretty neat. If you took the curve of the Earth, you could figure out the nautical miles, which would be a little bit longer, but we're not going to do that today. If you go to deck 5, you'll see what that is. I'll calculate that in a second. I'll do deck 5 and deck 15. I'll be right back and I'll put those up here so you can see them. Or better yet, why don't you do it and then see if we get the same answer. Okay? I'll be right back. Welcome back. Okay, so I ran some numbers, remember, so we were on deck 11, we had 12.67 miles. Deck 5, so coming down a little bit, will be 46.4 feet above the water. That gives us an H, and that's feet, that's miles, the height in miles. And that becomes 8.56 miles that you can see out. If you move up to the highest point of the ship I was on, which is 15, deck 15, it's 144.4 feet above the water. It's 0.0274 miles, and that gets me out to 14.8. So the furthest you can see out on the ship I was on was about 14.8 miles, and it's pretty cool. Now, what's interesting is this formula here, this one, would work for any planet and any height. So just any planet that's round, and all planets are round. If you want to find out the radius of Jupiter, you could find out how far out you could see on Jupiter, which would be much, much further. And then if you want to look at Mercury, you know, this is one of the smaller planets, you could see how far you could see there. So that's kind of an interesting twist. I'm not going to do it today, but if you want to, you can. And that's it. So take a practical problem, use some math, do a little thinking, use some calculus, use some algebra, grind through it. It was pretty nasty, pretty complicated to get there, but we did it. We solved it. And so this is the kind of stuff we do on our channel. If you learned something from this, please hit the like and leave us some comments about what you think. And then if you want to see more videos, please subscribe and hit the notification bell so when we put them up there, you'll get them. Thanks for watching. We'll see you next time.